Hi, welcome to the online UNG lab. In today's lab, we are going to look at density. So we are going to, in this lab, go through, take masses and volumes of a bunch of different cannonballs, these little circular things right here. And then we're going to look at the masses versus the volumes in order to determine the densities of our different substances. So let's just go ahead and get right in. I've got 5 samples here, ranging from A to E, where sample A has 2 cannonballs, sample B has 4 cannonballs, C has 6, D has 8, and then E has 1. It's our special one over here. So the first thing we want to do is we want to go ahead and weigh all of these out. So when we're using a balance, we're going to zero out what we don't actually want to include in the weight, which is these weigh boats. They're there to keep our cannonballs inside without rolling around, but we need them to not be accounted for in the mass itself. So we're going to zero it out. There's a zero tare button right here on the scale. And then we'll put our 2 cannonballs in, close it, make sure that no airflow is coming through, and then we are going to take our mass out to 3 decimal places. In the case of sample A, we have a mass of 2.816 grams. Any measurement you take should have as many significant figures as the instrument has the capability to give, and you also want to make sure you include your units, in this case grams. After going through and weighing out all of our samples, A through E, I got the following masses: 2.816 grams for A, 5.643 grams for B, 8.451 grams for C, 11.264 grams for D, and then 1.413 grams for E. You would expect that these are going to about double here as we're going from 2 to 4, and that's what we see. And then this is going to be approximately half the mass of this because this one has 2, while E only has 1. Remember, when we're talking about density, we're talking about mass over volume. So we've gotten our masses for all of our samples. Now we need to get our volumes. We're going to do this in 2 different ways. We're going to use a direct method, where we're going to be taking sample number E and determining its diameter, and from there we can figure out its volume. With the other samples, we're going to do what's called an indirect measurement, where we're going to do it by volume difference. So we're going to fill up our graduated cylinder with an amount of water. We're going to add our samples in, and then we're going to see what the difference in volume is between the initial with just the water and then the final after all of the cannonballs have been added in. So let's start with sample number E, and let's go ahead and get our diameter. So right here, we've got our caliper, and I've got the cannonball itself in between the 2 prongs of the caliper, and then I need to read the caliper. So reading the caliper, you want to look at where this 0 point is, and we can see right here that it is between 5, 6, and 7. It is right between right between 6 and 7, sorry. And we would say that our diameter is at least 6 milliliters. Sorry, is at least 6 millimeters. And then we want to determine our last digit. And we do this by seeing which of these tick marks here match with one of these tick marks. And okay. If we look right here, 0.6 matches up with this line right here, so we have 6.6 millimeter diameter. Our next part, we're going to take samples A through D and determine their volume with the indirect method. So I'm going to add some water into my graduated cylinder. It does not have to be a specific amount. You just are going to have to read it out to 2 decimal places. So I always make sure when I read my graduated cylinder that I'm eye level with the meniscus, the bottom of the water. And here, look at that. be 6.00. Fantastic. I'm then going to add in my 2 A samples, and I like to do this at an angle so I don't break my graduated cylinder. And make sure that there are no bubbles left over. And then I'm going to take my measurement again, and I am at 6.39. So my initial volume was 6.00 milliliters, and my end volume 6.39 milliliters. Go. Okay, after we've gone through and gotten all of our volume measurements, we have initial volumes for each one and final volumes. What you guys are going to need to do is take your final volumes, subtract out your initial volumes to get your volume of each of your cannonballs in milliliters. So you'll take the 6.39 minus 6.00 for sample A, and then 6.67 minus 5.96 for B, 6.45 minus 5.35 for C, and then 7.55 minus 6.05 for sample D. For sample E, we're doing the direct measurement. So we're going to take our radius and we're going to convert that from millimeters into centimeters, as the common unit for density is either grams per milliliter or grams per centimeters cubed. So we need to convert this millimeters into centimeters, and once we've done that, we can put it into our volume calculation. Remember, volume is equal to 4/3 pi r cubed. So we already have this in radius. We'll just put it into centimeters and then put that centimeter value in for this R value. And that should give us our volume of sample number E. All the rest of them, in order to get their densities, we're going to basically average through all of them by doing a plot. So, in order to do this, we want to plot our densities. Now, thinking about density, density is grams over milliliters. So we want this to be our rise, and then we want this to be our run. So this is our rise, this is our run. So our mass in grams will be on our y-axis. Our volume in milliliters will be on our x-axis, so that when we take all of our measurements, we have this line, and the slope will be equal